is Sairam Mudunga from MS21, Master Study in Structures, Trainee in Construct Design and Build Private Limited. First of all, I would like to say thanks to my mentors to allow me and my team to work on this prestigious project. Thank you very much, sir. Thank you very much, ma'am. And coming to my team, there are 10 members who have worked on this project. And coming to one by one, Mr. Shreya Siddharaj, who has appointed as a project manager for this project. And next, Mr. Harish Babu, who is appointed as a project engineer for this project. And coming to Deepak Joshi, who is appointed as AutoCAD engineer in this project. And Anil Prakash is BM modeler. And next, Hemant Bagde is the ETAPS modeler in this project. And Urmit Patel is Associate Design Engineer in this project. And Mr. Nitin Sabu is the Senior Structural Engineer in this project. And Mr. Mayank Anand, who is appointed as a BM Manager. And next is Mr. Lavmeet Singh, who is appointed as a Structural Design Engineer. Really, we are missing him today on this stage due to some issues. And once again, I would like to say thanks to our mentors who have supported us in this project from scratch to this stage. Thank you very much for one and all. And from here onwards, our project manager, Mr. Shreya Siddharaj, take it forward.
Hello everyone. Very good morning to you all. Good morning, sir. Good morning, ma'am. Good morning, mentors. I am Shreya Siddharaj. I am a project management trainee in eConstruct Design and Build Private Limited. I am assigned as project manager for this Group 1 project that has been assigned to us. Coming to our project, first of all, I would like to thank Mr. Sandeep sir for letting us participate in this event, which eventually made us learn a lot of things like time management and the other disciplined technical things. And it's really been a great learning journey for us in this couple of weeks. And coming to our mentors, they also helped us in a lot of things, like right from day one they have been behind us in supporting us. Thanks to my mentors also. And coming to my group, as a project manager and myself and my team leader, we shouldn't say this, but yes, we had been allotted designations like project manager and technical lead, but these hierarchies were not there while doing the project in our team members. Like there was complete knowledge sharing without any hierarchies. So coming to the project that we have been assigned. So before that, we had also worked on a couple of other projects also. And in every project that we did, we had just come up with one motto, which you can see it on the screen. It goes like strength, where S being strength, A for aesthetics, F for functioning, E for economical. We made sure we did every project with all these factors, elements, that no project should be left out with any of these entities. So with the same elements, we made sure. We had done some of the projects, as you can see these. So these are some of the projects done by my team members. Like you can see, there are a couple of structural projects and a couple of residential projects, where you can get to see a lot of contemporary things. Like if you take this is a residential come office building, and if you take this, even this is a yoga center with a residential house. So in such a way, my team members have worked on various projects which are all contemporary, which gives me immense pleasure to present you in front of you. So coming to the project now. So the project that has been given for us is a light project. This is basically in Bombay, and the clients are Airtel Developers, which is located in Elias Road, Mumbai. So about this project, firstly, as a project manager, I had to sit with the clients and the architects to grab the basic data. So you can see it on the slide. The basic data goes like this. Like we were asked to make G+43, where the client wanted 2 BHKs and 3 BHT units. So based on the areas given and the built-up area and based on their budget, we had come up like we can utilize 6,000 square feet in the whole area that they have given. So after all the discussions and sittings with architects and clients, we came to a conclusion that we should go with 6,000 square feet of built-up area. And by using all the 43 floors, these super built-up areas coming around 30,000 square feet. And about this basic things, like how to take forward the project. And I mean, as a project manager, I had 2 tasks in front of me. One is to give an ecological building for the client, and the other thing is to finish the project in time. So before that, I'd like to mention a point which our sir used to tell us, that you always have to work, based on the perspective of the end user. So when we sat and when we were planning, we had one thing, that how to make this project as good for ecological customers. So in that thoughtful process, we ended up and we thought that we should use BIM. So what is BIM? So this BIM technology, putting it in general terms, since many of you are youngsters, I would put it in the terms of bike. So imagine that a normal guy riding a normal scooter, and imagine a rider riding his motorcycle with all equipped like helmet and Alpine Stars coat and the big boots. So tell me, who would feel more secure? The normal guy who's riding all alone, or the guy who's equipped with all? Obviously, the guy who's equipped with all, right? So this BIM is something like that. So this has equipped. I mean, you can customize it, you can give all the disciplines, you can manage them, you can collaborate them. This is what BIM technology is about. So BIM technology is basically called as building information modeling, in which you can collaborate all the disciplines like architectural disciplines, structural, and MEP. So as you can see, we have clubbed all the disciplines using BIM. Yeah. So all these disciplines, I'll just state them. See, the basic thing, that is the primary thing, is of architectural plan. So from architectural plan, you can derive with the architectural model, and see, this is the plan, and from that we have come to the model, in which you have we have basically used Revit software for this, and this is the design model which is done by our structural team using ETABS, and this is one more elevation model of plumbing, which is the other discipline. For those of you, for general people who doesn't know, MEP is mechanical, electrical, plumbing, in which you can collaborate and you can merge all the elements. So if we go in depth, in depth of that elevation, you can see 2 of the typical plans that has been derived from Revit. One is for the plumbing, where you can visualize the plumbing fixtures, like there's a spout, there's a connection for the blue color line that you're seeing is cold water, and the red color line that you're seeing is hot water, and the green ones are sanitation pipes. So this is how you can actually virtually see them, like where your lines are going, where your fixtures are placed, and at what height they are placed, So that basically this will avoid discrepancies for skilled laborers. Let's say if some plumber is working, and let's say if you want to place a pipe, let's say there won't be a core cutting hole for him to take the pipe out. So in such cases, these things can be resolved by pre-planning in Revit. And this one is electrical drawing where you can see a typical house. This is one 3 BHK flat where you can see all the connections and the panels that we have connected. These are the tube lights for kitchen, and these are normal false ceiling fixtures. As you can see, this is one typical electrical plan. And similarly, we can do a lot of things in Revit for BIM technology. And this is one more thing that we can do is scheduling, where when you go to the execution stage, it becomes a problem for site engineer or quantity surveyors, and there will be a lot of time draining and energy loss. So all this BIM thing will do it for you by making the schedules and quantity takeoffs. And this one is the Navisworks, which could be used for clash detection and timeliner. So you can it will virtually show us where the clashes are there when you club it with different disciplines, and you can see the clashes that we have been resolved, and you can formulate all those with the proper documentation in Navisworks, which is again the BIM technology. And once they are done, you can also do a timeliner in Navisworks, which will actually give you a clear picture of how things and on what date the things will go. So there's one more thing called Bittrex Drive, which has been exclusively used by my company eConstruct. Basically, this is a project management software where you can it actually helps project managers to lesser their work. I'll tell you how it is. So this software makes the timelines, and it gives it implements the timeliners and the tasks allotted for them. So you can actually see them if the tasks are overdue or some things are overshooting. Such things you can monitor from this Bittrex Drive. So these are the things that you can do. So coming to the project, using all these resources, we have done the model, and you can see this is a typical floor plan where we have cut the section, and this goes like this, where the top ones that you are seeing are 2 BHKs, and this portion, the center portion that you can see is staircase, and there are lifts. You might think why there are so many lifts for just 4 units of houses. Since this is a G+43 and occupancy is more, we have made the calculations and divided, and we have come to a conclusion that we would need 6 lifts, so that it will lessen the discrepancies and disputes of the habitant or the end user. And these sites, you can see, this is a typical floor where it has 4 2 BHK units. So this is how you can do, and you can formulate and document all the quantities using Revit. And so the final data I'll be giving you at the end of the presentation. So now hereafter I would like to give it forward to my project engineer, Mr. Harish Babu. Thank you.
Thanks, Suresh. Good morning, everyone. My name is Harish. I am from eConstruct. Private Limited. Here we go for this project. I am allotted as a project engineer. So from here, this is a underway walkthrough of the building of a typical floor. We can see. Can you play? next year. Okay. Yeah, now we will see about the structural detailing or all. As it is a high-rise building, it is located in seismic zone 3. So in structural aspect we have taken more structural engineers for the structure because it is a high-rise building and it is located in Mumbai, that is in seismic zone 3. So we have taken more number of structural engineers, and with that we have taken BM engineers also for modeling that time period, time analysis, timeline things, and cost estimation and things. And we have, as a project engineer, we have divided as some disciplines like drafting. In drafting, our AutoCAD engineers take the plans of architecture and taking as a bit detail central line planning and structural planning and so on. And the materials we are recommended for the building is like shown in. And next, the load consideration for the building we have taken is brick loads and lift loads and water tank loads. And the analysis for the building we have taken is wind analysis, seismic analysis, and temperature analysis. And stability checks that we have taken as per the code references from IS 456. And for seismic analysis we have taken from IS 1893 2016. The stability checks we have done deflection and drifts and displacement against the wind and earthquake. And design we have done different number of elements like column, shear wall and footings. And the detailing we used detailing software, AutoCAD detailer. Like we can detail it in a very good manner in AutoCAD detailer. And everything in detail our technical team will be explaining you. And here we go here for a carried by Deepak Joshi. Thank you.
Thank you, Harish Babu. Good morning, very good morning to all of you.
Good morning.
First of all, my introduction. I am Joshi Deepak. I am training as a structural engineering in E-Construct Design Private Limited. For in this project, Elite G+43 residential building, I work as an AutoCAD engineer. So we got some data from architecture, that is a typical floor plans, means architectural plans. In this project, there are 5 podiums and 2 basements for the parking, 1 service floor. There are 6 lifts, 2 staircases for the accessibility, and 1 fire escape chute for the during emergency. 4 numbers of refugee areas in this project, in this building, at the 7th floor, 14th floor, 23rd floor, and 13th floor. The users of refugee area is the area or the site or one place is located in the building during during any emergency, the people or occupants can stay there if the evacuation is not possible or it's not safe. And in this building, there are 135 units of flats, out of which 106 is the 2 BHK, 27 numbers is 3 BHK, and one penthouse at the 43th floor of the terrace. And my work is starting from the drafting the center line plan. Then after we are drafting a structural framing plan, then superimpose plan by getting the help from our ETAP modeler, Mr. Hemant Bagre. And after all these things, we are starting drafting as a 2D plumbing drawing and 2D electrical drawings by getting assistance from our BI modeler, Anil Prakash. And after completing all our analysis and designing, we are started the AutoCAD detailing by getting the assistance from our senior structural engineer, Nitin Sabu. So we will discuss this next slide. All these are the typical floor plans of the electricals. This is electrical plans. Next, AutoCAD drafting team. Actually, this is a structural framing plan. It is also explained by our in-depth modeler, Mr. Hemant Bagre. Next, the superimposed plan. And now Anil Prakash will continue from the plumbing and electrical drawings. Thank you.
Good morning, everyone. Good morning, sir. Good morning, ma'am. My name is Anil Prakash. I am a management trainee of eConstruct. First of all, I would like to thank eConstruct for giving me this opportunity to work on this prestigious project. It is situated in Mumbai. It is G+43. So I would like to thank our mentors. Thank you, ma'am. Thank you, sir. And our group members. With their support and with their complete guidance, we have reached up to this stage. Now I will be explaining about the electrical typical plan. So we have almost 3 typical plans. This is our 2 BHK and this is our 2 BHK. Okay? So we have given one switchboard in every room, and if MCB is there in every apartment, we will be getting one MCB, and in the main hall or a lobby part, we will be getting an MCB for all the connections for the heavy appliances. And going to the next slide. This is our plumbing part, and next slide. We have explained this in this small. This is our complete fixtures we have used in this washroom. So these are the floor tabs we have used these are the floor tabs. These are the fixtures we have used. And the green color is for the sewage waste and blue color is for the normal water. This is our structure framing plan, which will be explained by our modeler, Mr. Hemant Bagre.
Thank you, Anil. Very good morning to all of you. I would like to introduce myself. I am Hemant Bagre and I am a trainee in eConstruct Designer Private Limited. And as I am a ETAP modeler in this Elite project, so I would like to explain about the structural framing plans and superimposed plan mathematical models and the beam releases given by in this project. So as per instruction given by our structural team and by reference of the architecture drawing, we have prepared this structural framing plan. If you see carefully in this structural framing plan, the discontinuous line shows the placing and the positions of the beam. And as an ETAP modeler, we are focused on the placement, and the offsets are coming from the beams in the room by the priorities. We are trying to adjust all these offsets inside the room by their considering by the priorities. So for maintaining aesthetic views, we are maintaining all these beams inside the wall. So as we are considering 4.5 inches wall, so obviously offsets are coming. So when we merge architecture and the structures when we plan, the new plans is come up, that is superimposed plan. Next slide. The superimposed plans give us a clear idea about what is the position of the beams with respect to the shear walls. So in this superimposed plan, we can you easily assume all these placement and the position of the beam, and I'm damn sure that there is no offset inside this particular plan. So after that, we have prepared the center line plan with the help of beam center line. So these center line plans helps to prepare the ETAP 3D models in the ETAP. After importing in ETAPs, we have prepared these all the 3D model in ETAPs. We have make sure that every elements of this entire structures we make sure that the every elements of this entire structures should be connected properly to each other. So this is the 3D views of our structure and the model. Next slide. Yeah, this is the mathematical model of entire structures, and this is blue line shows that the beams, and this is the shear walls, and this is the beam releases given by us as per the instructions given by our structural team. After that, yeah, we are assigned the nominal sizes of the beams and the shear walls in this particular project. So we are taking rebar of HYST 415 and HYST 500. So grade of concrete is M35 and M14. So as this project is located near to the Mumbai, this is the no issue for the grade of concrete, and we use the non-structural wall as a lightweight blocks. The sections property we have considered in this particular project is the beam sizes of 300 mm by 600 mm of M35 grade of concrete. After that, 230 by 500 of M35 grade of concrete. And after that, 150 into 300 of M35 grade of concrete. This beams is used for the service slab, and we are considering column as a 500 mm by 500 mm of M40 grade of concrete. After that, we are assigned the wall sections. We are assigned the two wall sections of shear wall, 300 mm thick of M40 grade of concrete. After 500 mm of M40 grade of concrete, we are assigned the various slabs like general parking, staircase, and OST LMRs. So we have assigned 150 mm thick of M35 grade of concrete slab, and the remaining slabs are 200 mm thick of M35 grade of concrete. So we are also assigned all these area loads. We are considering the various area loads by. So in this, the general area loads we are considering lobby, staircase, bar, WC, terrace, OST, LMR1, LMR2, parking, service slab, and swimming pool. These are loads we are considering from IS 875 part 1 for dead load and IS 875 of part 2. So this is about all the sections properties and the planning of our projects. So I would like to invite Urmik to explain about the detail and analyze and detailing parts. Thank you.
We have done some harsh analysis in this. In this, we have done earthquake analysis. So in this earthquake analysis, we got to know that that our building is safe in earthquake or not. That means while there is an earthquake, if our building is stiff, it will not resist earthquake. So it should be, our building should be some ductile to resist that earthquake. In P delta analysis, why we have done that? Because of the self weight of the building, as it is G+43, its self weight will be huge, and due to that the lateral force which will be coming, And so due to that lateral force and the self weight of the building, there will be the extra bending moment which will try to fail the building. It should not happen, so we have taken care by that P delta analysis. And due to the self weight of the building, the compression forces which will be coming on the columns and shear walls. So the columns and shear wall should not fail, and that is why we have done. So it should not fail. That is why we have done the buckling analysis. And in wind analysis, the wind, as it is G+43 structure, beautiful structure, as the wind will be governing on the top of the building. So it should not fail in stability checks. Means due to wind, our stability of the building should not be failed. So we have done the wind analysis. In temperature analysis, due to the temperature, there will be extra stresses on the building, majorly on terrace and the outermost elements of the building. And due to that stresses, the members should not fail. That is why we have done the temperature analysis. And in creep analysis, we have checked that if there is a load for the deflection that are for a maximum number of years, that like in the lifespan of the building, our building should sustain that deflection. So we have done the creep analysis. So in this is the seismic base shear analysis, which is earthquake analysis. Base shear means the lateral force coming on at the base of the building. That is due to earthquake. That is base shear. We have calculated the static base shear, which is VB, and it is calculated by AH into W. AH is the horizontal acceleration and W is the self weight of the building. Horizontal acceleration is calculated by Z by 2 into SA by G into I by R, and Z is the seismic zone, and is as our building is located in Mumbai, we have taken zone as 3 and zone factor as 0.16, and I importance factor as in our building. As in our building, the population is more than 200. We have taken importance factor as 1.2, and we have taken response factor as 4 because we have designed the shear wall as ductile shear wall and RC frames as ordinary frames, and as site our basement in near substructure, there was hard rock, so we have taken site type as 1, and as per IS 1893 part 1 2016, the time period we have taken is 0.09 H upon root D because infill wall are present in our structure. So here the H is the total height of the building and D is the lateral dimension in x and y direction at plinth level. So time period in x direction is 2.17 seconds and time period in y direction is 2.79 seconds. So in seismic, this is the dynamic base shear. As our building, as our total building height is 154.55 meter. So as per IS 1893 part 1 2016, we have to do the dynamic base shear. In this dynamic base shear, we do scaling. That is, we scale our static base shear with dynamic base shear, as dynamic base shear is comes as an earthquake in the building. So we have done scaling. In this, EX and EY are static base shear, spec X and spec Y are dynamic base shear. We have scaled it, and we have cracked the model in service and strength, as we are considering that in the lifespan of the building, the concrete will effective will be some percent, it will not act fully. So we have cracked it, and we have scaled the dynamic base shear to static base shear. Wind analysis, as our total height of the building and this lateral dimension of the building is greater than 5, and and the 1 by t, which is time period, is less than 1. So as per IS 875 part 3, we are doing wind analysis, that is dynamic analysis, which is also called gust analysis. So in this, we have calculated by this formula wind load Cf into A into Pz into G, where G is the gust factor. In this, the force coefficient in x and y direction, where the height of the building, that is h by v ratio. H is the from plinth level to the top terrace level, that is the height, and h by v is 5. B is the least lateral dimension of the building, and A by B is 1.65, and the force coefficient is 1.2, and for CFY it is 1.4. Next. Effective frontal area is the area in which the force will be half of the above story and half of the below story. So we have calculated for all the stories, and we have find that the critical one is for top stories. So in x direction and y direction it is 101.26 and 167.69 meters. Pz is the design pressure at any height, and we can calculate it by 0.6 Vz square. Vz square is the design wind pressure, which will act as which will act due to Vb, K1, K2 and K3, where it is basic wind speed, probability factor, terrain and height factor, topography factor. So we have got the design pressure as 762.13 Newton per meter square. Next. G is the gust factor. We have calculated it from graph, that is GFR and LH value. We have got that. And next, background factor, we have got it from this graph by calculating that formula. Next, size reduction factor, we have got a 0.04 by calculating that lambda x formula from this graph. We have got that. Next, gust energy factor, we have got as 0.06 by calculating that formula from graph. This is the gust factor. We have got 1.95. And wind load in x and y direction is 180.59 and 375.74. As I have told you, we have got this critical one at the top story. And wind based shear is 13,020 kilonewton, and in y direction it is 6,216.33 kilonewton. Next, model participating mass ratio will be explained by Sairam Mudumba. I would like to call him. Thank you.
Thank you, Urmit. And I would like to give a brief review about my project. And first of all, we took this project into our hands. We analyzed that what are the resources we have, and how can we divide the team, and how can we work efficiently. Then we divided the team into some departments: AutoCAD, structural and structural assisting team, and the site location team, and all those things. After these all explanations and ETABS modeling and stability checks, now we have to analyze the model. So after analysis, we will get some results. So we are going to look into those results right now. First of all, we have to check the modal mass participation. First of all, we have to know that what is modal mass participation. We all have smartphones, right? Say yes or no? Yes. We all have smartphones. There is one snapshot option is there. If we click the capture button continuously, every snap will capture for certain seconds, right? So if someone is throwing a ball like this, if we capture the phone like this and hold the capture button, that phone will record every movement of the person. So you can see how he is rotating, how he is throwing the ball for every second. So that is the modal mass participation in our structural case. So we are going to see the model, how it is behaving while seismic earthquake event is happening. So those are the modes we have considered, total 17 modes according to the damping ratio, and those are the time periods and the rotation values. You can check the all values on the table, and guidelines for the modal mass participation. Everything we need a reference, right? What we are doing, why we are doing that. So we have to go through the reference. So those are the references we took from the Indian Standard Codes. So Indian Standard Codes is saying that in previous code there is a one thumb rule. First mode time period should be the 0.1 into n. N is nothing but number of structural levels. How height is our building. So according to that, the first mode time period should be happen. First of all, what is the time period? Time period is the period taken by the structure to take one first oscillation. So that is the first mode time period. So that should be under control. So in our case, that should be the according to the thumb rule, that is it has to be 4.8, but in our case this is the 5.8. Little more high means our structure is little flexible. So we can say that it is safe. Why? Because structure should be ductile. It has to participate when earthquake is coming. Can I generalize this? I can generalize this with one example. If you have a dog with a tight belt and you are holding that tightly in your hand, so dog is trying to move forward with maximum energy, you are holding it very tightly. So in our case also, here we can observe two cases. You are holding the belt very tightly, but your dog is moving forward with high energy. What will happen? Dog will die with that belt, right? So in second case, you are holding it very loose. It will escape from you. Everything is damaged for us, right? In our structural case also, if we make the structure very stiff, like pencil, if earthquake or seismic force will hit that, it will break easily. But in our general example, we have to release some force to the dog, and we have to carry with the dog. Then only it is safe for dog and ourselves also. In our structure also, we have to release some movement in the structure to participate in the earthquake event. So that is the ductility in the structure. That's why our structure is safe. This is little more flexible and participating in the seismic analysis. And remaining things are according to the code. First mode and second mode time period should be greater than 10%. And in third mode, structure should participate more than 65% in lateral directions. In final mode, in our case, final mode is the 17th mode. Structure is, you can observe the structure is participating 96% is in x direction and 95% is in y direction. So in modal mass participation, everything is okay in our structure. And next, coming to the gravity deflections. We have two types of deflections. Earthquake and gravity force. We all know that earthquake will come like this. This is the lateral force. And wind is also applying laterally to the structure. So coming to lateral force, and completely these forces will go to the earth, right. So lateral forces are converting into vertical gravity force and going down. So this is the gravity deflection in our building, and this is also under control. And these are the lateral deflections, deflection in x direction and y direction. And these are the stability checks we have conducted mainly for concentrated on these things. What are interstory drifts? According to IS standard, it has to be 0.004 in both directions. It is safe. And coming to the displacement. So just now we discussed about the displacement. Building it due to the lateral forces, building is going to displace with a certain time period. We can relate this to modal mass participation. So displacement is under control. So our building is safe. We are providing correct ductility to our building. So we can conclude from here, we can relate this thing to the modal mass participation again. And coming to the deflection. Deflection is also safe in our case. Just now we shown that gravity deflection and lateral deflection images. How our building going to deflect. And these are the values and proofs for the deflection is under control. And coming to the torsion, we can simplify that torsion is nothing but rotation. Somebody is everybody knows about center of mass and center of rigidity. So those two in the asymmetry in the building. If we cut, can you go to the plan once? Yeah, this is our building. If we cut the section like this is unsymmetric. If we cut the section like this, the building is symmetric. Due to the unsymmetry in the one direction, center of mass and center of rigidity points are at two different places. So somebody hitting you at one place and your reaction from the other place. So rotation will happen in structure, right? That is called torsion in our case. So this is the torsion. You can observe clearly in this shape. This is the elevation of the building. After torsion, that will be the structure elevation. And we are going to take care of the torsion also. And this is the soft story. Soft story means weakness in the stiffness. We have service floors and refuse floors with lesser height than typical floors. So there is a chance, there is a less stiffness than above floor, right? That's why soft story will happen. What is soft story? So soft story means if I am standing like this, one of my leg was little weak. So somebody hit me, I will fall down easily. Otherwise, I am very healthy and I am very stable. Somebody hit me with the same force, I will resist up to somewhere. So that will be the soft story. In our service floor, we got 21st story and service floor at the 6th level is the soft stories, and we are designing our structure to that soft story effect also. You can see that is the soft story. Bottom story stiffness will be less than 70% of the upper story. Those are the criteria of soft story. We are taking care of the soft story also in this structure. And these frame designs. After analysis, what is the next step? Design of the structure, preliminary design of the structure. So, with the inputs of all analysis details, we are confirmed that our building is stable. So after that, we are planning to design the structure. These are the criteria: preliminary design results and final design results we use after so many iterations like soil structure interaction, foundation design, all those things. Our all frames are passing. So we are provided very economical and optimized structures in this project to reduce the project cost. So we are not using heavy structures to increase the dead load of the structure. We are using proper section sizes. We can make sure that. And those are the column percentages. Those are the column percentages. IS code saying that you can take up to 6%. Minimum it has to be 0.8% and 6%. See, we all know that concrete cost is much lesser than steel cost. Yes or no? Steel cost is increasing day by day. So how much steel we can reduce in the structure by increasing the concrete? By compensate, concrete is good in compression. Steel is also good in compression and tension. So we are using rebar to increase the tensile strength. So we don't need to increase up to 5% or 6%. So we can optimize this also by compensating the strength with concrete also. So we use the technique in this and we limited the maximum rebar percentage in the column up to 2.5% only. In this steel case also our structure is very economical. And these are the shear wall designs we did in this project. And you can observe that what is the lateral reinforcement, longitudinal reinforcement, shear reinforcement we got. We are designed and detailed according to these reinforcement values, which is given by software ETABS. And this is the slab design we did in ETABS, which is placed as 10 mm rod and 200 center to center. And these are the foundation details. Coming to foundation details, our senior structural engineer, Mr. Nitin Sabu, will explain about foundation. Thank you.
To all. My name is Nitin Sabu. I am from the MS20 structures batch, and I am here to explain about the foundation part. Before that, I would like to thank Mr. Sir, ma'am, and our members for helping us. With our team, we got a G+43 elite structure, and it was a prestigious project to work on. And my designation in the team was a senior structural engineer. As a senior structural engineer, my responsibility was to coordinate with all other structural team and to make our structure as stable and economical as possible. Coming to the foundation part, we use the CSI SAFE software to design and detail the foundation. And from the ETABS model, these are the base reactions that we got from the ETABS after designing the ETABS superstructure. These are the base reactions. In that, dead load and live load are the major governing parameters. And since there was a basement in our structure, we opted for a raft foundation. And the size of the raft foundation was 42 meter into 52.5 meter approximately. And we varied the depth so that we can reduce the cost from 3 meter to 1.5 meter and to 0.6 meter. And the grade of concrete we used was M40. We provided drops also of size 3400 mm and 1800 mm. Since there was a retaining wall surrounding the basement, we could not go beyond that retaining wall also, so we provided a beam of size 400 cross 900 surrounding the basement. These are the footings layout. As I told earlier, now we decreased the size. Those are 600 mm depth slab foundation. Middle one is 3000 mm thick, and the other one is a 1500 mm thick foundation. After modeling, we went for foundation checks. Main checks were ground bearing pressure. The allowable ground bearing pressure we got from our geotechnical team was 1400 kilonewton per mm square, and the allowable settlement for raft was 50 mm. the subgrade models, which is mainly the support data, it is given as a safe bearing capacity of soil by the allowable settlement. We calculated it and found it as 28,000 kilonewton per meter square per meter. And the allowable, the maximum soil bearing pressure we got was 660.14 kilonewton per meter square. You might think that this is very uneconomical, but coming to the steel part, I will explain it later. The GBP, so it was safe in GBP also. Next slide. Coming to the settlement, maximum allowable settlement was 50 mm, but we got only 23.57. Here also you will think that this is the uneconomical, but I will explain it later on. Next slide. These are the foundation service load combination and strength load combination used. Service load combination was used to check the punching shear, one-way shear, and for the moment in service envelope for crack width checking. Strength load combination was used to design the structure. For checking the punching shear, we use the default values from the CSI safe, but for shear wall it won't show the value, so we cross-checked it with the S13 and S23 at a distance of D/2 from the face of the column. For one-way shear also, we checked the S13 and S23 at a distance D from the face of the column. Maximum stress for found was 0.98 Newton per mm square and 0.92 Newton per mm square. The allowable one was 0.16 root FCK, which was coming as 1.01, so it was safe. And coming to the steel part, this was a major challenging part since it was a G+43. The rebar was coming so high, and our requirement in safe was 40 mm dia bar at 50 mm spacing. So we could not give that much spacing also. So our major challenge with our mentor's help, we provided 40 mm bar and 150 mm spacing in 3 layers in both X and Y direction. That was the major challenge we were facing. And for bottom steel, we used a non-linear cracked. We changed the dead load and live load condition from linear to non-linear cracked stage. And for top steel, we changed the load case from non-linear allow uplift case. And the steel coming in X and Y direction was 32 mm dia bar at 125 mm spacing in both X and Y direction. Now coming to the crack width, we calculated the moment from the service envelope and calculated the moment in M11, that is X direction, M22 in Y direction, and found the maximum moment. And the crack width calculation was done using the Excel sheet, and we calculated the AST depth, everything we inputted, and found the crack width was 0.18, 0.18, 0.19 and 0.14. The permissible value was 0.2 mm, hence it was safe. And coming to the soil structure interaction, nowadays the earthquake comes the response of the not only the superstructure but the combined effect of substructure and superstructure also is very much important. That's why we exported the raft again back to the ETAP and checked how the structure combinedly the structure behaves. This was the percentage of steel before soil structure interaction, that was after the soil structure interaction, and we verified that all our members passed even after the soil structure interaction. Thank you all, and I would like to invite Sairam for explaining PBD and detailing part.
This is the detailing part. After designing the structure and all the elements of the structure, we have to give our drawings to the site, which are very easily understandable by the site engineers or clients who are working at the sites. So we worked from the that perspective. We detailed our design to very easy manner by using SP34 sheets and our mentor's help. And you can see that this is the beam detailing help. In this we provided main rebars and curtailment rebars and different sections of that. This is the column detailing. We provided 4-legged styrofoam in 2 manners. That is just because of column size is 500 and 500, that much shear reinforcement is required in that column. And coming to the beam detailing, beam and column detailing schedules. For detailing, we use AutoCAD detailer software as of now. So these are the schedules and the bars, the shapes given by the software. And we are going to send these detailed drawings to the site for execution. This is the shear wall detailing. We use 32 dia number bars and 40 number bars at the 4 corners. And those are the 16 dia bars at the 250 mm center to center as the shear bars, which is going horizontally in the shear wall. And coming to the foundation details, as per our senior structural engineer explained, that was the difficulties we faced in the foundation steel detailing, designing, and just because of that, we provided 3 layers of steel of 32 dia in 3 layers with 150 center to center. Is according to IS 456, it is very difficult to place the 32 dia bar in 50 mm spacing. Why? Because everyone knows that segregation will happen, that mesh action will form, and aggregate will go somewhere else, and concrete mix will come. Due to solve those difficulties, we arranged this layer. And coming to the performance based design, this is the new topic according to ASCE 41. We did performance based design to our structure. And coming to performance based design, what is performance based design? Everyone will purchase mobiles, laptops, everything by spending some money. When we are spending some money, we will expect that much performance from the equipment we are going to purchase. Realme mobiles got blasted so many. Redmi Note 4, I think so. After that, they are also started this performance section. They are also announcing that my mobiles are this much performing. No more mobile will blast. They are announcing that thing. So just for small mobile, one laptop, they are doing performance based design. Why not we do performance based design for our G+43 structure? Why not we can show our building is performing well? We are designing the building, we are analyzing the building, this much very confident team and this much confident structure. Why we are not showing that our structure is performing well while doing earthquake or wind effects also? So we are decided to do the performance based design for our building, and now we are showing the performance based design. PVD, where it originated. Actually, in 1971, I think 1971 to 94, in between periods, California was affected by a lot of earthquakes. Maximum magnitude of earthquake was 5.8 recorded. So all of the businessmen, when this month earthquake was come, so everything was disturbed and collapsed. The business sector and all those things were shut down. This is the economical loss to the country or whatever it is, right? So after affecting all those earthquakes was in the period, the owners of the buildings and businessmen started asking engineers, what you are doing, man? When earthquake coming, my building was collapsed. What is the design purpose? Why you are constructing this building? So at that time, owners want to know that if next earthquake will come, how my building will perform? Can I stay in there or can I run away? So they decided to know about that performance of the structure. At that point, engineers started working on the performance based design. So from that point now onwards, they are still working on the performance based design. So we will see the glimpse of the performance based design we added to our structure. And what is the purpose of structure? Is our structure performing well during the earthquake or not? We can say that every structure will perform. Some structures designed according to the codal basis, but does not perform well in the earthquake. And some structures doesn't meet the codal requirements, but perform well in the earthquake. Why it is happening? This will happen between communication difference between the designers and the site people, execution people. So we want to know about the performance checks here. This is the process, how we are going to performance-based design. First, we have to select the performance objectives. So, how our building should be performed. There are certain, these performance objectives will depend on the client requirement. Why? Because he is paying money for every structure, right? So, we have to design the structure according to the client perspective. How he wants his building. He has to his building perform very well in the earthquake, and he has to occupy the building immediately without any damage. We can do further. And there is a life safety. Building strength will lose, and there is no damage to the human life. We can design for that also. And collapse prevention. Building will lose lot of strength, but client has to ready to accept the several damages also. That will be the performance objectives. Design engineers can sit with the clients and discuss the economy, how much it will go, and how he wants the performance. And after that, perform preliminary design. Designers will go for preliminary design of the structure, and they will analyze that our preliminary design is suitable for that requirement or not. If yes, they will go for construction. If no, again same, they will go for again preliminary design. They will do some modifications in the design and come back to the capability test. So that will happen in the performance based design. These I just said performance objectives will depend on two factors. One is operational immediate occupancy, life safety, collapse prevention. How client required his building after earthquake depends on that it will happen. And in the design parameters we will consider that design base share. X percentage of design base share we are going to increase it. This is the iterative process. In our structure, we consider our design uncracked base shear to the 30 times increased, and our structure is safe. We are X percentage of the structure, X percentage of effect we are increasing. Earthquake effect. For example, one earthquake is hitting with some force, we are increasing that force to some extent. In this our project, we increased that to 30 times and checked in this project. We will see the results later. And this is the energy diagram we will get from ETAPS while doing performance-based design. When earthquake is happening, deflection will not start immediately. After potential energy, kinetic energy and modal damping, structure will start deflecting. But everything will happen in fraction of seconds. In major thing I want to mention here, we are going to deal with mm's and seconds, not with meters and hours. We are discussing from last 1 hour, but we are dealing with fraction of seconds and mm's. You can see the stability checks also, those are 100 mm, 150 mm. The structure is failing in mm, but earthquake is happening in seconds. So if our building perform well in those seconds and that mm distances, we are safe. We are, as a design engineers, clients, owners, everybody will safe in those seconds and mm's gap. And this is the dashboard. We can see that we use time history analysis to do this performance based design. We can see that, and this is the base share of the time history analysis. And this is the major part. We can rate our structure from here onwards. We just discussed life safety, immediate occupancy, collapse prevention, performance. So what are those? We already explained. In immediate occupancy, little non-structural damages will happen, like fall ceiling patches, plastering patches will fall down, like that. They can. There is no need of repairing either. They can occupy after earthquake immediately. In life safety, small structural strength will lose some extent, but still it's safe. No emergency repair will require. So in that cases, we can see that in the bottom bar they are mentioning that from green color, that is the immediate occupancy, and after that blue color is the life safety. In our structure, while we are doing performance based design, we are proudly announcing that we got immediate occupancy hinges at some places, and life safety hinges only at 2 places. These are, you can see that these are the blue colored dots which are representing life safety hinges, and green colored dots are the immediate occupancy hinges. With the reference of this, we can go to next slide. With the reference of this, US Resilience Council is rating the buildings according to these norms. According to our previous slide, our building will rated as 5-star in US Resiliency. Coming to this project, this is our overview of our project, and now we want to show some documents to you people regarding this project. First, we will go through design basis report of this structure. This is the design basis report we are going to submit to the client or owner of the structure. And from last 1 hour, whatever we discussed, we are going to mention each and everything in detail. How load calculation will happen with the calculation formulas. What are the loads we are considered to the structure. What material he has to use, and what are the considerations and design parameters and factors. You can go through the DBR. And we are mentioning each and everything: superstructure, centerline plan, mathematical model, how we give beam releases, what are the support conditions, what are the section sizes we are provide. These are all, we can see the load calculations. For how much people we considered water requirement, for how many days. He can know about all those things from this DBR, and he can provide according to this. And these are the stability checks we discussed right now. And from here onwards, foundation design will start. What are the foundation sets we did, and how it will be. Is it safe or not? We are going to convince the client our structure is safe. We are protected. So this is the report we are going to submit. And then onwards, for this much high-rise building, we have to get NOC from the high-rise committee. Now we are going to see that for high-rise committee report also, high-rise committee form. We have to fill each and every details about the design parameters in this high-rise committee form, and we have to submit it to the people who are in the high-rise committee. Then only, if everything is okay, they approve our building and to construct. That will happen with this high-rise committee form. We fill each and every design detail in this. You can see the model mass participation, and where is the cantilever is coming, how much cantilever length is coming, what are the load, what is the deflection, how much deflection is happening in the building, how it displacing, what are the drifts, every design parameter we are going to mention, what are the materials. Next we are going to see the wind tunnel analysis. Actually in this project we assigned wind gust dynamic analysis, but after this we are planning to do the wind tunnel analysis also to check the performance in this analysis also. In this wind tunnel they will create our one model according to the environmental cases, and they will apply the actual forces artificially in their lab. We did with RWD. And they will assign actual forces in this laboratory, and they will check how building will deflecting actually with that forces with the all environment parameters. This is the wind tunnel report for our project, and how this report contains how they did wind tunnel analysis, what are the parameters they considered, everything will included in this, and what are the load combinations suggested by those people after the analysis. And we have to design for those load combinations also, and we can check that for those load combinations our building is safe or not. And this is the model how they are going to perform wind tunnel. And these are the moment graphs and force graphs they analyze after. They will mention that where we are getting high frequencies, where we are getting high forces, where we have to take care about structure according to the wind and all those things. This is the high frequency force table they are going to use in the wind tunnel analysis. And they will give some suggestions according to our building also. And this is our final layout. We are going to plan this wind tunnel analysis, and we are going to design our building to this wind tunnel analysis also. And next we have some BOQs and rate analysis part.
Hello again. So I'm sure this is the most interesting part for in perspective of the client. As you can see the quantities that we have generalized, since this is not in detail. You can see the basic quantities for the earthwork. The main things we have notified them, and this goes like this, like the concrete that would be requiring for the project. And since the building is very humongous, the numbers are very huge here, which a common man may find it exaggerated. So after getting all the quantities, we have just considered, made a rate analysis of the basic materials. But I would like to add one more point that the rates that we have taken are just the basic rates, and it would change based on the location. If it is Karnataka, it would go on KPWD, and if it is Maharashtra, it would go on the Maharashtra State Board's PWD. As I could say, this is the basic cost of the building, and you can add the charges based on the State Board's PWD. So that's it. So this would be the entire cost of the building. Thank you.
that too with just 2 weeks and with just 8 to 10 people, right? So, just few questions actually as a formality. What was the base shear of the earthquake and the weight differentiation? Anybody?
Yeah, it's 7,000.
For earthquake?
Yes, sir. 5,974 for the earthquake base shear,
Mhm.
and 13,020 kilonewtons is the wind base shear.
So it's a wind governing structure, is that?
Yes, sir.
Alright, so have you checked the deflection for the strike design or the cracked model or uncracked model?
For service track mode, we check.
And that was less than span by.
So that has to be less than span by 3.
So it was there.
Yeah, it is.
Okay. Another thing is what was the difference between the center of mass and center of stiffness?
Center of mass can change anywhere. Why? Because
I'm talking about the distance between x and y distance between the center of mass and center of
we
distance.
got 4.21 meters around.
Okay, so 4 meters and that too actually in the first mode you could be able to reduce the torsion. So that's really wonderful. Alright, so did you get a chance to work on value engineering by any chance?
Yeah, from starting onwards we designed with the optimum sectional sizes, and after that every iteration we have increased little more. Then value engineering already happened in the process even.
So that's why you given 500 by 500 column on the top of the terrace?
No sir, columns are at up to podium level only. From the basement up to podium level only there are columns and complete shear walls.
The shear walls, what was the reduction?
We have started from 300, sir. Actually, some of the shear walls are 300 mm thick. Due to control the rotation and third mode participation, we have tried with 400 mm thick shear wall also in different iterations at the different locations. It doesn't work out. That's why we increased some more shear walls to 500.
Yeah. Okay, fantastic. Please give a round of applause. Thank you very much.